So in this exercise, we aren't actually going to plot any function or work out any value. We're actually going to work with composite functions involving a piecewise function. But before we go on to that, I think it would be helpful to actually revise composite functions. So let's just ignore this for a minute and go over composite functions really quickly. If I have a function f of x is equal to, let's say, x squared, let's use something simple, and another function g of x is equal to x minus 3. And I asked you to find f circle g of x, or the notation that I prefer, we have f of, can use the square bracket, g of x. Okay, these two mean the same thing. It just depends on which notation you want to use. I like this notation. Okay, so we're going to use this here. This means take the g of x function, which is this one, and put it into the f function here. So how do we do that? Well, we look at the f function. It is x squared. Now, wherever you have an x in the f function, what I want you to do is write out a big bracket. And then after you've written out all your brackets in place of x, just complete the remaining operations. So we had a square of that x. We're now going to have a square of the bracket. We are putting the g of x function into f. Then what is the g of x function? It is x minus 3. So in place of your bracket, wherever you had that in the f function, insert x minus 3 into your bracket. And this is now f of g of x. Okay, there's your function f of g of x. And that's how simple it is. Let's just do it in terms of g of f of x. So let's say we wanted this. We wanted g circle f, or g of f of x. So what this means now is that we are inserting the f function here, the f function, into the g function. So we are inserting this function here into the g function. So we are inserting into the g function. So here's the g function. In place of x, I have an x there. I'm going to write out a bracket. So we have bracket, and then complete my remaining operations. And I'm going to write down the minus 3. I'm inserting the f function into g of x. What's my f function? X squared. So I'm going to insert x squared in place of my brackets, and there's my answer. Okay, this is going to be g of f of x. There we go. And we can get rid of that bracket. It will just be x squared minus 3. So that's how we work with combining functions in terms of composite functions. Now let's go on to the exercise 3 example. Okay, so firstly, what we need to do is find f circle g of x. So that is the same as finding f of g of x. So what we are doing is we are taking the g function and inserting it into the f function. But notice the f function is a piecewise function. So what I'm going to do is I'm going to write this piecewise function out because I'm inserting another function into it. But wherever I find x, I'm going to write it with a bracket. I'm going to replace the x with a bracket. So this is going to be open curly bracket here. Let's just shrink this so I have space. There we go. Okay, so it's x squared. So I'm going to write bracket squared. And then notice, okay, we have the domain. Now you may be asking yourself, should I put a bracket in the domain? Wherever I have x in the domain, ask yourself, do you see an x there? Yes, I see x is greater than or equal to 5. So I see an x there. I'm going to put a bracket. So it's going to be semicolon or colon, bracket greater than or equal to 5. And then we have, there's a square sign here. We have x minus 2 whenever x is less than 5. So we'll have bracket minus 2. Let's make this bracket a bit bigger. Minus 2 whenever bracket x, because we have an x there, so bracket less than 5. And we are inserting the g function into the f function. So wherever I have my brackets now, I'm going to insert the g function, which is x minus 3. So we're going to have x minus 3, x minus 3, x minus 3, x minus 3. And now we don't want to leave it like this. Let's simplify it. So this is equal to, in fact, let's write it out here. F of g of x is equal to x minus 3 all squared. You can leave it like that, or you can expand it if you want to. The expanded version is x squared minus 6x plus 9 whenever. And here we need to solve this inequality in terms of x. So take the negative 3 over onto the other side. We are going to get x is greater than 5 minus 3. That becomes 5 plus 3, which is 8. And then at the bottom, we will have x minus 3 minus 2, that's x minus 5. And then we have the same, a similar inequality. So we take the minus 3 over onto the other side, we'll have x is less than positive 8. And this is the function f of g of x. Now we need to work with the other part of the question, g circle f of x, or g of f of x. So let's make some space here. Okay, let's get this out of the way. Right, we are dealing with g circle f of x, or as I like to write it, g of f of x. Okay, now what are we doing here? We are taking the f of x function, so we are taking the piecewise function and inserting it into the g of x function, that linear function x minus 3. Now, there's something peculiar about this. So I said we are inserting it into the g of x function. Let's write out a bracket wherever we see x and then minus 3. In fact, let's make this bracket bigger. You'll see why we need to. So we are going to insert this piecewise function, the f function, into g. How do we do that? Let's look at the piecewise function. Okay, we have x squared wherever x is greater than or equal to 5. So by right, what we should do following those rules is take this function here and insert it into my bracket. So what we are going to do is have x squared whenever x is greater than or equal to 5. But let's stop here, see if this makes sense. We have an equation. Okay, remember this is supposed to give an output value. And now we have x squared wherever x is greater than or equal to 5 minus 3. This doesn't look like an expression. We have a restriction involved in this expression. The restriction should go behind or after the expression. So to handle this, what we do is we are just going to take the function part of the first part of the piecewise function. So the function portion is the x squared, and the restriction will go to the end unaffected. So what we are going to have is this. Our function portion of the first part is x squared. So we are going to insert x squared here. And then we will have minus 3. So let's just write that here, minus 3. And then we are going to take our restriction and insert it at the end. Now it looks nice and tidy. Instead of having the restriction as part of the function, that just looks weird. Okay, so this is going to be the first part of the new piecewise function, because remember, we have another part to deal with. That's how I know this is going to be a piecewise function. Okay, let's deal with the second part. So we are inserting the f function into the g of x function, and the g of x function is x minus 3, so bracket minus 3. Let's make this bracket bigger, minus 3. So we're inserting the function portion of the second part, which is x minus 2, into the g of x function. So we are going to have x minus 2 in the bracket, and the restriction will go toward the end, at the end of the function, so x less than 5. Otherwise, we'd have something looking like this. X minus 2 whenever x less than 5, and then we'd have minus 3 here. And this just looks weird. I haven't seen a function defined like this where the restriction is inside the function. That's just crazy. So this is your answer. Okay, and then what we can do is simplify it. So the first part will just become x squared minus 3 whenever x is greater than or equal to positive 5. And we can simplify that, x minus 5 whenever x is less than positive 5. And that's how you handle this example. Let's move on to the last one, exercise 4. So this example is much like the previous one. You're just finding composite function. you're not going to sketch this one. So let's go through it. We need to find f circle g of x, or as I like to write it, f of g of x. There we go. So what we are doing is we are taking the x squared minus 3 function, the g function, and inserting it into the piecewise function. So we are going to insert that quadratic function into the piecewise function. So our resulting composite function is also going to be a piecewise function. Let's deal with the first part. Wherever I see an x, I'm going to write a bracket. We're going to have 3 bracket minus 4, and then we have the restriction or the interval bracket. I have an x here greater than or equal to minus 7. And then let's deal with the second portion. We have sine of x, so sine of bracket. There we go. Let's make this bracket bigger. Whenever x, so we have an x there, so I'm going to have brackets less than minus 7. And now we are inserting the g of x function into the f function. So wherever I have my brackets, I'm going to insert x squared minus 3, which is the g of x function. So we are going to have x squared minus 3, x squared minus 3, x squared minus 3 here, x squared minus 3. And now we can simplify. So let's simplify this. So it's going to be a piecewise function. So we are going to have 3x squared, 3 times 3x squared minus 3. So it will become 3x squared. And 3 times the minus 3 is going to become minus 9. Minus 4, it's going to give us minus 13. And then we need to take the minus 3 over on the other side. We are going to have x squared is greater than or equal to minus 4. And then we need to simplify the second part. We will have sine of x squared minus 3. We can't really simplify that any further. Okay, and then we need to simplify that. We will have x squared less than minus 4. But before we go on to the next part of this question and find g circle f, let's just take a look at these intervals because they look peculiar. So we should be simplifying those intervals. We want those intervals in terms of x, not x squared. But before we go and do complicated math, let's just take a look at this. X squared is a parabola. It looks like so. Okay, this value here is always going to be either 0 if you insert x is equal to 0 or positive. Ask yourself, what x value can you insert into x squared that will make the output less than minus 4? Just think about that for a moment. There's no such x value that you can insert into this that will cause it to be less than minus 4. It will never be negative. Hence, we can totally disregard this portion of the function because we will never get a situation where x squared is less than minus 4. That will never happen, unless, of course, you're dealing with some imaginary numbers, but that's not the case here. We're just looking at real numbers. So since this interval here at the bottom of the second part will never be satisfied, we can just ignore it and we can take out the first part of this function, sorry, the second part of this function. And then let's take a look at this. This value here, if I look at x squared and I have to insert an x value into it, the answer is either always going to be positive or it could be 0 if I insert x is equal to 0. But this value is always going to be positive or obviously 0 if you insert 0, but it's always going to be greater than or equal to negative 4 because if you look at a parabola of x squared, the parabola always lies above y is equal to minus 4. It's always lying above this horizontal line. So this function here, or that value there, that interval can be simplified to x is an element of real numbers because no matter what x value insert into x squared, it's always going to be greater than or equal to negative 4. So this is your simplified function. F of g of x is just equal to 3x squared minus 13. And in fact, you don't even need to include that x is an element of real numbers restriction. You can if you want to, but it's not really necessary. So that's how you get f circle g of x. Okay, let's look at g of f of x. Okay, so we have G circle f of x. So I like to write that as G of f of x. Okay, and what we are doing here is we are inserting the piecewise function into the G function. So following the similar rules that we did in exercise 3, or the similar technique, we are going to get a piecewise function. So we have x squared minus 3. Wherever I have an x value, I'm going to have a bracket. So bracket squared minus 3. And we insert the function portion of the first part. The function portion is 3x minus 4. So we're going to have 3x minus 4 in the bracket squared. And then the restriction, x is greater than or equal to minus 7. That's going to come after the function portion. X is greater than or equal to minus 7. And then we just do a similar thing with the second part. So we have x squared minus 3. So we're going to have bracket squared minus 3. And then we are inserting sine x. So that's the function portion of the second part. Sine x into the g of x function. So it's going to be sine of x. And that's going to be squared and then subtract 3. And then the interval comes last. So we have x is less than negative 7. And then we can simplify this. So if we had to expand that, okay, let's expand it. So it will be 9x squared minus 24x plus, it is going to be plus 16. And then we have a minus 3. The plus 16 minus 3, that will become plus 13 whenever x is greater than or equal to negative 7. And there's no real major simplification for this. We can just write it as sine squared x minus 3 wherever x is less than minus 7. Take a look at the intervals. We don't really need to simplify that. We can't simplify those intervals, so we leave it as is. And that is how we handle example 4. So that brings us to the end of this video. Hopefully you better understand the section that I've covered. If you found value in this lesson, hit that like button and consider subscribing to be updated whenever new content is released. Thanks for watching.